So, before we actually start configuring something, a little bit more theory on how to get from a command line to metacodes. So, an example is a programmed line that's one ANSI line with a G1, a couple of coordinates, x, y, a feed rate, and probably a spindle speed and M3 to actually have the spindle rotating. With these lines, the controller, DLL, the parser, will produce a metacode G1. It will produce a metacode X with a parameter that is a value, and that has the value 100. It will produce a metacode Y, similar with just a different value. It produces a metacode F that contains the feed rate, also with a value. A metacode S, and you guess what? Produces a value with the number after S, and a metacode M3. And then, like I said, once you have all these metacodes, you need to assign functionality, and that is done making use of kernel commands. We will see that in the documentation. So on a G1 we will set the motion type to linear. On X we will set the joint value X to the value that we've got from the parser. Similar for Y. For F there's a set feed, and so on. And we will use those concepts to get our ANSI program, our first ANSI program with just a G0 move up and running. So I will go into Machine Configurator, and to configure metacodes you have to go into the command section. Here you configure everything. Then in Machine Configurator you can select which file you want to modify. Typically you will want to modify your current file. So current file means you modify your MCF. In case you have sourced in one or multiple CCF files, you can select them from a list to see what kind of functionality is defined in the library, and if you have access to it you can also modify the library directly from Machine Configurator. But in most cases we will use current file. The command section so far is empty. So the first thing, if you make a right mouse click, is to be able to add a metacode group. Since in the end you will have many metacodes or commands, a lot of G codes, a lot of M codes, a lot of addresses, your file will get pretty long, or the list will get pretty long. That's why we came up with the capability to group them and create metacode groups. The name of the metacode group doesn't play a role, so you can call it whatever you want. Typically we have a metacode group called G codes. Let's add the S. Then another one for M codes, and another one for addresses. You can rearrange them using drag and drop if it works. Well, it doesn't work for G-code groups. Funny. So now we have a group with an arbitrary name, and here we need to add a G command. So with once again with right mouse click you will get a menu providing you with the capabilities of the parser. So these are basically the Siemens commands that the Siemens parser knows. If you select a different controller here, you will get a different menu here. On Fano controller you will not have these Siemens commands section, for example. Of course G commands and M commands you will find for most controllers. So to configure a G0 I will select G commands. Then you will get a list where you can select specifically which G code you want to configure. That's just a G, which is something that we do not have in this case. If you go over here with the mouse you get a tooltip, and that shows you also programming example. So the G metacode, the first one that is selected here, you will just do in case you have something like you can see here in the bottom right of the tooltip, a G in square bracket 3 equals something. If you come across something like that, you have to use that one. In most cases you will use the G with an arbitrary integer behind. So an example here is G54, but also our G0. fits into this category. So I will select that one, click OK. Then Machine Configurator asks you to type in the number. So instead of int, I'm just typing in my G0, and that defines my G0 metacode. I can right away test what happens now. So if you remember in the last training session, if I simulated my ANSI program with G0X0, I got an error message that the metacode G0 was not found. So if I now save my MCF file and go back to NX and simulate my program again, I can, since I'm still in ISV, I can read in the MCF file again by pressing reset. So now my changes from that I just made, adding the G0 metacode, should have been adopted by CSE. So you can now step, and you still get an error message, but a different one. So this means in our program we just got a little step further, and now we get the message that X is unknown. So this tells you, okay, obviously I need a X metacode definition. ABC, UVW, XYZ, feed, speed are typically added to the addresses section. So I go to addresses, select the metacode group addresses, and then you see all the addresses that our Siemens 840D parser will know. And that's, for example, an X metacode. So I will select that one, click OK, and I've added it. In this case, since the X doesn't have a number or something, I'm ready to go. So if I save it, again, we can test that in NX. I reset it, click step, and now you see my line G0X0 was processed. I can see X100. Also this one is processed, but the machine does not yet move. The reason for that is I did not have, or I haven't defined a behavior yet. So far, if I look at my G0 configuration, you have capabilities to define the behavior, and by default we have selected do nothing. This means the code will just be ignored. The other options that you have is to just consume some time. That's a value in seconds, so that would wait 10 milliseconds. The next option that you have is to call a subprogram, or the third one, or fourth one, is to call a method. We will get to that later on and make use of that. What we will use for the moment is to use customized command. That is something that is only available in the advanced version of Machine Configurator, and it allows you to get access to the programming capabilities that we will use now. Before you go in here, you should configure your XML editor. So I'm using XML Notepad, so in the settings make sure that you've configured an XML editor of your choice here. So if you now go to Edit Metacode, it will open up XML editor and show you some kind of a structure, and actually that's automatically filled out. I can delete that, I don't need it. And an execute block, and under the execute block you can now add functionality. So what do I need? I need to define the behavior of a G0. To look that up, I go into my reference manual that lists all the kernel commands that are available in CSE. And this is structured in a couple of sections. The whole kernel commands are found here in the first section. Then there is, I told you that it is per controller capable, we have the capability to extend the functionality. That's documented here in the controller specific commands for 840D, for example. And also we have here the AnyController commands, also documented, but you can also find that in the NX help. So the main section that we will need is the common kernel commands. So we need a G0, and we need the correct functionality to define the behavior of a G0. And if you look through this list, there's something about standard motions. That will probably be a good choice, and select motion type. And that gives you an extensive well, hopefully extensive documentation about what the command does, which parameters it takes, and a description of what the parameters may do. So in this case, we have a command setMotionType with one parameter, and the parameter can be either linear, rapid, circular, left, right, and so on. So what we need is two options. We need to define G0, so that can be either rapid or linear rapid. The difference between both is described here. Basically on the 830D we have the behavior that also in G0 the tooltip describes a linear path, so that's why we'll use linear rapid. So we need a command setMotionType and a parameter linear rapid. To add that, I will make right mouse click here, insert an element, and I want to add that as a child below execute. That's how we need to do that. And then we're using a schema so that you get some help on how to configure the file in the correct format. So in this case we need to execute a kernel command. So I click on kernel command, make once again right mouse click, add an element as a child. Then the right syntax is that now we need to have a name field, and in the name field I type my setMotionType. And then add another element, again as a child, as a parameter, and now we need to specify the parameter. The parameter is of type string, and in case the parameter is of type string, you need to enclose that in quotation marks. So I need to write the quotation mark, linear rapid, and close the quotation mark. So that's the definition for my G0. That's sufficient. I don't need anything else. Related to the structure, just adopt it. That's the structure that we have, and the schema file will help you to use the correct structure. Then I close it. XML editor asks you to save. Of course I want to do that. And then this is stored here in the command. Good. So we have defined the behavior for the G0 metacode. The next thing would be to define a behavior for my address X. So also here we need to set a joint value. So I also need to go to Customize Commands. And first of all I will use the documentation to find out what is required. And in the setMotions section of my documentation I can also find that here there's a setJointValue command, so that sets the joint value for a specific axis. This command, if you read the documentation, has 3 parameters, and the last one is optional, indicated by the square brackets. The first parameter is the name of the joint that should be moved. The second parameter is the value, the target value that it should get. And the third parameter is the positioning mode. That's basically whether you would like to use absolutely or relevant or relative, which is similar or which is the same as incremental mode. That some controllers call it incremental mode. So we will use this command to define what happens on the X. So I go to Customize Commands, open it in my XML notepad. Insert an element as a child, select commands, command, add another child with a name to avoid typing errors. So if you the CSE is case sensitive, so if you want to avoid typing errors, you can copy and paste that. So I copy the joint value from the documentation and paste it in here. But there's one problem with that. If you make a double click on those here in the documentation, for some reason Windows automatically selects also a blank after that, and that causes problems. So if you look at here, we have a blank afterwards. If you have that, you will get error messages in the execution of the X metacode, and these are really errors that are very difficult to find. So really please pay attention that if you do copy and paste, that you always delete the blank or make sure that there are no blanks. I've also seen that people manage it to get new lines by pressing Control Return. You can get new lines here that also produces error messages. So really make sure that you don't have new lines or any blanks, and that the command is really spelled correctly, also with the correct small and capital letters. So set joint value. The next parameter is the joint name. So after this one, I insert a parameter, and the name of the joint is the x-axis. This is what I want to move. The joint name is a string parameter, that's why I use quotation marks again. The third parameter is the value. As you might have noticed, Machine Configurator on the X address produces a parameter that is called value. You find that already also here, and you can use this as kind of a you can see it as a variable that you can use. So the third parameter that I will add here, elements as after as a parameter, and the third parameter is the value. So you can see this as a function call. The function name is x. The function has two parameters. One is called value and one is called flag. We will see what the flag is for later on. And for the value, you can just use this parameter as a variable inside your execution or execute definition, and feed it into set joint value. I will not use the third optional parameter for the positioning mode. We will see that later if we define G90 or G91 for absolute and incremental mode. So that's it for the moment. I will save that. Of course, I also need to save my MCF file. So once I've done that, we can see what happens if we execute our program again. Last time we executed it, we just ignored the code, so nothing moved. Let's see what happens now. So I press reset to load in the MCF file again, press step, and then of course obviously my axis is still in the 0 position, so G0 X0 does not do anything. But let's see what happens on X100, and surprise surprise, our machine starts to move. So we have our first movement of the machine. We can then now try to enhance that. Go simulate machine code file again, edit our program, and for example make a X minus 100 and X 100 again, just to get some additional motions. Simulate that, and it seems to work. Also the time calculation, you will already see a time calculation, and basically per line CSE will make the calculation of the motion based on the axis parameter. So the X100 move from 0 to 100 will accelerate the axis with the maximum acceleration specified in the file, then move with constant velocity, that is the maximum speed of the axis, and then decelerate again to reach the position of 100. One of the great benefits of using parser technology and the LexYAC technology that we have is that once you've defined that, you have huge flexibility on how to program your lines. So for example, on the Siemens, instead of writing X100, you can also program X equals 100, or you can program X equals and then start calculations. So for example, 50 times 4 or something like that. And you can already produce that. You can also try what happens if instead of making a capital X, you're using a small one. I will save the program and simulate it again. So x equals 100. I did not change anything in my MCF file, but CSE processes it correctly. X is equals and then a calculation, which in the end should be 200. You can actually also see that if you switch on machine coordinates, then you can see the coordinates. So now we're moving to 200, and with a small x, it also works. CSE or the parser knows that the Siemens controller also accepts small and capital letters. So without having to change anything in your MCF file, you can process all these lines. So that's the first step to get our machine moving.